Hello everyone, welcome back to my channel. Yes, this is my channel physics slash course. Uh, Before you see all my explanation, don't forget to subscribe or comment and or likes. Thank you very much. Okay, we go directly see this question. This is question about the mathematics paper 4 mechanics 1 or M1. This is syllabus 9709 code for 1 on May June 2015. We have 1 hour 5 minutes to solve these problems, but actually this is my explanation. Probably this is not same with much care. If you find something wrong, please let me know about this. Okay, now we directly to number one. Particle of mass 0.6 kilogram. Um, Sorry, we draw it. Yeah, with, let's say this is particle. Yeah, 0.6 kilogram. Drop from the height 8 meter above a ground. Let's say this is a trace. Sorry, yes. Oh, this is around 8 meter. Yes, I want to draw it, but why didn't? Oh, sorry, this. Yes, let's say this is traced off until the ground. Yeah, until the ground. Sorry. Oops. Yes, until this is, let's say this is ground. Okay. The speed of the particle instant before hits the ground is 10 centimeter. So we have if we see here is, yes, until hit the ground, the velocity is 10 meter per second. Okay, fine work done. Again, error system. Okay, we know this is about drop the initial velocity is zero. This is come from meter per second in the yes. So if we draw it about the force on the trace, he it going down. Yeah, so we have we draw about sorry. Mm, we want to draw the force. Sorry, this is about weight. This is about mg, and also we have this is about a resistance with direction go up. Let's say this is R. Okay. Yes. If we know about the motion on this particle, we will use the total force on the particle, yeah, mg minus resistance force equals to ma. We want to find the how magnitude r. Yeah. If we see the acceleration is about acceleration, we will use the v square equals to u square plus 2ad, or we find this is 10 square. uh, let's say we say 10 square is 10. We cannot use this here because this is 0 plus 2a and d is 8 meter. Yes, we can find the acceleration is 100 divided by 16. 100 by 16, 6.25 meter second square. Okay, finally we get the acceleration of this object uh, what is it? Yeah. Okay. Now back to here again. Yeah. Uh, mg is 0.6 times, let's say the gravitational is 10, and r is what we will find, and mass is 0.6, and acceleration is 6.25. Okay, we get this is 6 minus r equals to, we find with calculator, 6.25 times with 0.6, 3.75, 3.75. So we get r equals to 6. Oh, sorry, we will find this is around 0.6 times with 6 to 7.5. Oh, sorry, this is 7.5. I think this is wrong. Yeah. Okay, we get r equals to 6 minus 3.75. This is 2.25 Newton. Yes, this is the r, or resistance of the air, yeah, acting on this object. So work done, yeah, work done is force times distance. So we get work done equals to force is 2.25 times with 8. So we get work done equals to, we use calculator, 2.25 times with 8 equal to 18. Yes, 18 joule. Okay, finally we get the uh, work done is equals to 18 joules. Okay, we'll continue number 2. A particle mass of 0.8 kilogram is projected with a speed 12 meters per second up a line greater slope of a rough plane inclined at 10 to horizontal. The coefficient of friction between the particle the plane is 0.4. Okay, we draw it first about the rough plane. Yeah, so let's say this is rough plane with inclined. Uh, oops, sorry, this is actually directly we solve this a little bit fault, but this is the inclined is 10 degree, and projectile, let's say this is about the particle, small particle. Okay, let's say this is the small particle with mass 0.8 kilograms and projectile with velocity 12 meter per second. Yeah, yeah, yeah. Sorry, 12 meter per second. Going to rough upland go to slope, incline it 10 degrees to the horizontal. The coefficient of friction between particle here is 0.4. Okay, this is the rough plane. Yeah, find the acceleration of the particle. Okay. mm, 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 mm. Okay, let's say A equals to F divided by mass. Then if we know the F is mg sine theta, theta is 10 directly, and this is divided by mass. So if we get uh, A equals to G sine 10, or if we calculate this, I'll use calculator. Then sine times 10. This is around 1.74 meter per second square. Okay, finally we get the about the acceleration around 1.74 meter per second square. Yes. Uh, Find the distance the particle move up the plane before coming to rest. Yeah. Okay, we can find by v square equals to VO square plus 2AD. Oops, we don't have D here. Yeah. Oh, sorry. I think this is I have wrong way about because we have frictional force. Yeah. Okay. This is still because we have frictional force. This is also mu 0.4 times with mg cos 10. Oh, yeah. Okay, I think also okay. And let's say mg m will be correct when we what will cancel it. Yeah, this is about g sine theta minus 0.4 g cos theta. Okay, we will find first by my calculator. This is still 1.74 minus g cos theta times with 4 cos. Oh, here 3.94, and then we get 1.7 negative 2.20. Yes, 2.20 negative, yeah, in meter per second. Why negative? Because they have um, frictional force. Oh, I forget. We don't know about the direction. About the direction, here is plus. Here is plus. Here also plus. Yeah. But everything is negative. Yeah, because this is about the direction, it opposite with the motion, is negative. Everything is negative. Yes. Okay, sorry, this is so wrong. Yeah, not 2.2, but this is around, we calculate first. 1.74 plus 3 point, sorry, 1.74 plus 3.94. It's this is 5.68. 5.68 meter second minus 2, or meter per second square. Okay, sorry about this wrong. Yeah, because if we know, I will draw first about the force. Yeah, this is the first is uh, this is mg. Yeah, this is mg cos mg, and this is mg cos 10, and also this is mg sin. Okay, what about normal contact force? Normal contact force is in here. This is opposite with the mg cos, and this is perpendicular with plane. Yeah, or make a right angle with the plane. Then frictional force is going down on the slab here. This is about the frictional force. Yes, that's the conclusion of this number question, I find the acceleration of the particle. Sorry, we actually draw first about the force acting on this particle. This is about because we don't know about frictional force, also mg sin. Yeah, the direction actually, if the particle going sliding up, this is the force, all the force is going down. So the sign negative here is because the all the parameter in opposite direction. Yeah, okay, we continue the question 2. This is find the distance of the particle move up the plane before coming to rest. Okay, we know from this here we have 12 meter second, and then we come to rest, we have the final velocity is come to zero, and then we have a. So we cannot use formula, we can use formula vt equals to vo plus at. Oh my god, we don't have t. Okay guys, um we don't have t, also we don't have d, we don't have time, also we don't have distance, but we have a. We find t first day. Okay, um v come to rest is 0. 0 equals to 12 minus a is 5.68 times t. Finally, we get t equals to 12 divided by 5.68. We use calculator here. 12 divided by 5.68, and then we get 2.11. The time taken is 2.11 second. Okay, finally after that we can use the distance equals to VOT, VO times T plus a half AT square. Yeah. Uh, D equals to 12 times with 2.11 plus a half of A. A is negative 5.68 times with T square. 2.11 times 2.11. Okay, we use calculator again. This is about 12 times 2.11. It's become 25.32. Negative, always calculator first. 2.11 times 2.11 divided by 2, and then times with 5.68. We get 12.64. And then if we summarize, this is let's say minus 25.3. Yes, this is around 12.676, so maybe 68, yeah, meter. Yes, this is the answer. Distance is, yeah, the distance until the particle come to rest is around 12 meter. Okay, guys, we will continue number three. To like inexstability string are attached to particle with 25 Newton. The string pass over two smooth fixed pulleys and have particle of weight A Newton and B Newton. Hanging vertical in their end, the sloping parts to 30 degree and 40 respectively with the vertical. See diagrams. Yeah, the system in equilibrium. Find value of A and B. Okay, there is no question more about number three. Yeah, we can use the mm, let's say this is okay. We use um, Cartesian diagram. Oops, sorry. Okay, let's say we have this is about 25 Newton. 25 Newton. Okay, and we have A Newton and B Newton. This is A Newton with 30 degree here, and also we have B Newton with angle 40 degree. This is B Newton. Okay, we're gonna find A and B. Yeah, how to find? We can use the Newton first law about the equilibrium. Yeah, if we B or A separated into x and y diagram, so we get here is B sine 40, and also we have B on the y direction. This is around B cos theta. Okay, we get the separated of B. Yeah, over A we have also the same thing with B, and we get here is use this. This is A cos 30. This is for B cos 30, then this is for A cos 30. Yeah, and also we have A sin 30. Okay, finally we get the some factors for force on the y and x direction. Yeah, and then after that we can use uh, the definition of force, yeah, in x and y. If the on equilibrium, that total force equals to 0. Yeah, okay. And in the, let's say in the x-axis, yeah, we have sorry as oh, on the x-axis we have b sine 40 minus a sine 30. It will become 0. Yeah, okay. Or b sine 40 equals to a sine 30 in the x axis. Yeah, so by the y direction here, on the y axis, yeah, we have, sorry, b cos 40 plus a cos 30 minus 25 same with 0 equal to 0. Okay, then if we want to find, let's say find a first, yeah, then b is on the meaning of a. Let's say this is like this one, this is b equals to sine 30 div sorry sine 30 divided by sine 40 times a. Okay, let me let me copy this, yeah, as a b. Come to here, yeah. Oops. Yes, this is a b time with cos 40, yeah, plus a cos 30 equals to 25. Okay, continue. Finally we get about a, yeah, a equals to, sorry, we calculate first with my handphone. Sin 30 divided by sin. Oh, sorry. Sin 40. 0 point. This is about 0.5 divided by 0.64 bracket cos 40 0.77, then A plus 30 cos 0.87 A equals to 25. So we calculate first about the left side. 0.5 times with 0.77 divided by 0.64 equals to, this is 0.83 A equals to plus 0.87. This is about A equals to 25. Yes, plus 0.87. 1.7. This is 1.7 A equals to 25. Yes, we get A equal, sorry, 25 divided by 1.7. Yeah. 1588 Newton. Okay, finally we get the A. So what about about B? Yeah, yes. B is yes, this sine 30. Yeah, sine 30 is a half 40 sine 0.64 0.64 a half divided by 0.6 times 1588. Yes, this is around 12.41 Newton. Okay. Finally, we get the A and B. Yeah, that's A is here. Yeah, and B is here. Yeah, A and B. Okay, continue to the next number. Number 4. Yeah, a car miss 8 kilogram moving up a hill inclined at theta to the horizontal, whereas sin theta is 0.15. The initial speed of car is 8 meter second minus 1. 12 seconds later, the car has traveled 120 meter up the hill and has speed 14 meter second minus 1. Okay, find the change in kinetic energy and change in gravitational potential energy of the car. We have a different velocity. Also, we have about different height. Okay, change kinetic energy is a half mass v square minus u square, or equals a half mass is 800 times with v square 14 times 14, and initial is 8 times 8. So I will use the calculator first. Yeah, 14 times 14 minus 64 uh, times with 400. Yes, with 14 times 14 equals 6 minus 6 4 equals times 400, 52800 joule. Okay, this is a change of energy. How about change in kinetic potential energy? Change potential energy. This is about mg h2 minus h1. Also, we have m equals to 800 g. Let's say this is 10, yeah. And h1 is 120 meter minus, start from 0. Okay, we calculate first with my calculator. uh, this is 800 times with 120, 960 kilo joule. Okay, we get it. We have change in potential energy. Also, we have change in kinetic energy. So, what the next is? Yeah, we don't know. Let's refine what we have to do after we do here. Okay, the engine of cars working at constant rate 32 kilowatt. Find the total work done against the resistive force during the 12 seconds. Okay, we have about different things: energy and kinetic and potential. So if we calculate, yeah, different with potential energy change minus kinetic energy change is work done by engine. Also work done by resistive force. Yeah, against resistive force. Oh, we can calculate that this is find the total work done. Wait. G potential energy minus work done by resistive force. Let's say we did R, yeah, that's equals to change is change in kinetic energy plus engine force work done by engine. So change potential energy is 690,000. Work done by resistive force, it will be fine. And this is kinetic energy change is 52 kilojoule plus work done by engine force is oh, I see, this is about PT 30 kilowatt times T. T is 12 second. Okay, finally we can find work done by resistive force equals to this calculator first. We calculate about 32,000 times with 12. This is as the work done by engine equals something and plus with 52 kilojoule equals to something and then minus 9 6 oh, I'm sorry, this is I think something went wrong. No, it's okay. 96000. Yes, 5 to 4 joule. Yes, finally we get it. Yes, this is work done by work done against the resistive force. Okay, continue number 5. A particle P moves its straight line ABCD with constant deceleration. The velocity P at A, B, and C are 20 meter second minus 1, 12 meter second 1, and 6 meters respectively. Find the ratio distance AB, BC. Wow. Constant deceleration. Okay. AB, BC. Okay, let's talk about the trace move. Yeah. Let's say this is point A. let's say this is point B. We don't know it's proportional or no. We have the point A velocity is 20 meter per second, and then point B is 12 meter per second, and then C is this is 6 meter per second. Okay, find the ratio ABBC. ABBC. The duration is constant. Yeah, the duration is constant. So we get the A, it's equals, yeah, we can use the formula, uh, let's say V square equals to U square plus 2D, I'm sorry, 2ED. So what about D? Oh, wait. D is V square minus U square and divided by what? 2A. Yes. So if find D at point AB, yeah, D at the point AB, yeah, equals to 12 square minus 20 square then divided by 2A. And what about DBC? Yeah, let's say here DBC is 6 square minus 12 square divided by 2A. Then if we know DAB ratio with DBC, it's equals 12 is 144, yeah, minus 20 square is 400 divided by 36 minus 144. So if we calculate, this is same thing with, wait, we use calculator first, yeah, 144 divided by, sorry, 144 minus 400 is equals to 2 negative, yeah, negative 256 and divided by 36 minus 144, 108, negative also. Then the ratio is 256 divided by 108. Yes, this is around 2.37. Yes, this is about the ratio, yeah, ratio between distance in AB and distance in BC. Yeah, we have finally around 2.7 ratio. Okay, now question II. the particle comes to rest at D. Oh, we don't know where D. Given that the distance AD is 80 meter, find the distance BC. Oh my god, how to solve this? Oh, AD is 80 and come to rest. Okay, we find first about the acceleration. How the acceleration is the distance is, let's say we use v square equals to u square plus 2ad. Come to rest 0 square is 0. U square is 20 times 20 plus 2a, and d is 80 meters. Sorry, this is, yeah, 80 meter. So we get a is negative. We use calculator first. Yeah. 400 divided by 160. 2.5. Yeah, 2.5 meter per second square. Okay. So find the distance BC. Distance BC. We can use VO, V at B plus times T. Oh, we don't have T. We don't have T. We can use back to VC square equals to VB square plus 2AD. Okay, we will to find D. VC is 6. 6 square equals to VB. Oh, what VB? VB is 12. 12 square plus 2. A is negative 2.5 times D. Okay, we got. This is wrong. We say that about 144 minus 36 and divided by 5. Yay, we get this is D equals to 21.6 meter. Okay, yes. Then question 6. Okay, we'll continue to question 6 and 7, but don't forget to subscribe, like our comment. Don't forget to subscribe. Yeah, subscribe. Yeah, I think wrong. Subscribe on my YouTube channel as physics course/course. Yes, by me Widodo Waluyo, come from Indonesia. I will continue for the number 6 and 7. Yeah, this is the part 1. I will continue at the part 2. Yes, thank you very much for your watching my video. Yeah, thank you for watching my video. Yeah, and we will continue to part 1. Thank you very much. See you. Bye bye.